Hello and welcome. As environmental health officers, you're on the front line, and you know that solid data is everything when it comes to local air quality management. So today, we're doing a deep dive into our trusty workhorse, the nitrogen dioxide diffusion tube. Let's get into how we can make absolutely sure that every single tube gives us the quality evidence we need to protect public health. So here's what we're going to cover. We'll kick things off with the why, our legal mandate. Then we'll get hands-on with the tube itself and the best ways to use it. After that, we'll get into the nitty-gritty of the data, and finally, we'll see how it all comes together to make a real difference in our communities. Right, first things first, let's talk fundamentals. Why are we out there, in all weathers, changing these little tubes month after month? Well, it all boils down to our statutory duty under the UK's air quality strategy. We're so focused on NO₂ because out of all the nitrogen oxides, it's the one with the clearest links to respiratory problems. It's a nasty byproduct of pretty much any high-temperature combustion, and honestly, it's the main reason we end up declaring air quality management areas. It really is central to everything we do in LAQM. Now, this is where it gets interesting. If you look at the national picture, it seems like industry and power are the big players. But when you zoom right into our towns and cities, the story completely changes. For us, on the ground, road transport is by far the dominant source we're dealing with right at the curbside. And that's our biggest challenge. And here are the goalposts. These aren't just suggestions. They're the legal standards we have to work towards. Our entire diffusion tube monitoring program is designed to see if we're meeting that critical 40 microgram per cubic meter annual average. Okay, let's talk about the tool of the trade, the PALMS-type diffusion tube. It's simple, it's cheap, and you know what? When you use it correctly, it is an incredibly powerful way to map pollution hotspots right across your authority. At first glance, it looks like a pretty simple bit of kit, doesn't it? You've got your acrylic tube, usually 7.1 centimeters long, a couple of plastic end caps, and then the really important bit, 2 little stainless steel grids. These grids are coated with a chemical called triethanolamine, or TEA, and they sit right at the closed end of the tube. So how on earth does it work? Well, it's just pure physics. It all runs on a principle called molecular diffusion. You see, the NO₂ molecules in the outside air, where there's a higher concentration, naturally want to move up the tube towards the coated grids, where the concentration is basically zero. They just travel down that gradient. And the crucial thing to remember is, this isn't some kind of guesswork. The speed of that movement is all governed by a scientific principle called Fick's law of diffusion. What that means for us, in simple terms, is that the law lets us take the tube's dimensions, how long it's been out, and how much pollutant it's collected, and from that, we can calculate the average concentration in the air. It's proper science. Right, now we're getting to the part where what we do in the field has the biggest impact on our data quality, deployment. Getting this bit right is absolutely 100% critical if you want results you can stand over. And this picture, well, it says it all, doesn't it? On the left, you've got a perfectly sighted tube on a lamppost, with a spacer giving it room to breathe. On the right, it's slapped right up against a wall. That's a classic mistake that can starve the tube of air and give you a false low reading. That's the difference between valid data and, frankly, useless data. These here are the golden rules. Always vertical, open end pointing down to keep the rain out. That 5-centimeter spacer block is completely non-negotiable. It stops weird effects from the surface it's mounted on. We need air to flow freely, so stay away from recesses or thick bushes. And definitely keep clear of building corners that create little whirlwinds, because that turbulence can mess up the diffusion path and give you a false high reading. Sticking to these is just paramount. So once we've collected our tubes after their 4 or 5 weeks out in the wild, the job's not over. Not by a long shot. The raw numbers that come back from the lab need some careful handling to make sure they're accurate, reliable, and comparable with everyone else's. Okay, first, let's be really clear about what we're dealing with. This is an indicative technique. Diffusion tubes are absolutely brilliant for getting a wide map of pollution levels, but they just don't have the same pinpoint accuracy as a massive, expensive reference analyzer. We have to accept that there's an uncertainty, usually around plus or minus 25%, and we have to account for it. So that brings us to the million-dollar question for data quality, doesn't it? We know there are these uncertainties, so how do we correct for the systematic biases that can creep in, both from the lab and from just being out in the field? And the answer is the bias adjustment factor. This is a brilliant, nationally derived number that Defra publishes. It's worked out from dozens of studies all over the UK where people run tubes right next to a high-tech reference monitor. Applying this factor to our raw data corrects for those systematic errors and, crucially, makes our results properly comparable to the legal air quality objectives. It's really useful to know where this bias comes from. Wind turbulence can cause an overreads, and there's even some complex chemistry that can happen inside the tube itself. On the flip side, very cold, dry weather can make the absorbent less efficient, leading to an underread. This is exactly why having a standardized, national adjustment process is so vital for all of us. Okay, let's zoom out for a second and look at the payoff. All this meticulous work, the careful positioning, the data adjustments, what's it all for? Well, it provides the rock-solid evidence we need to take real, meaningful action to protect people's health.
And this is a perfect example of where it gets really powerful: source apportionment. When we combine our high-quality monitoring data with things like traffic counts, we can actually start to pinpoint which types of vehicles are causing the biggest part of the problem at a specific spot. And that is just invaluable when you're trying to design smart, targeted solutions.
At the end of the day, your data is the legal trigger. It's what allows you to declare an air quality management area, an AQMA. It's the evidence that underpins your air quality action plan. And it even feeds directly into the public health outcomes framework, which tracks the mortality burden from air pollution. Your work puts a number on that local health impact. So I guess that's the final thought to leave you with. The care and the rigor that you put into your fieldwork today directly shapes the strength, the defensibility, and ultimately the success of the public health protections you can put in place tomorrow. The quality of your data is the quality of your action plan.